Today was originally planned to just be like a work day, so I'll kind of keep everything the same and kind of go over what you can do to get ready for this test tomorrow. Again, I hope with all the extra review days you had last week, that you really do feel kind of like on top of this topic and ready for this test. Um, just to kind of go over all of this again, nothing is new what I'm going to say. But as you're getting ready for your test, things you definitely want to make sure is done. First, want to definitely make sure that your homework is complete. Um, Most everyone completed homework 1 and 2 before the quiz, so that doesn't really apply to most people. But definitely want to go through and make sure you've completed homework 3, which was the book work, homework 4, which was the integrating quotients. Remember, you only had to do 2 questions per row. Definitely can go back and do more questions if you want the extra practice. And then don't forget about homework 0, which will have every unit. That's just going to be some AP review. And then the other thing you want to begin working on is, of course, the briefcase binder. I know, at least from the people in class I could see, many people were starting to work on this last week. You have the quick reference, which is a lot of formulas that you want to make sure you have memorized, especially the new trig ones, the new exponential ones, and then the natural log rule. The unit summary, and again, my recommendation for the unit summary is to maybe do some types of questions that you typically have trouble with, if it's like trig rewriting or exponential rewriting, and kind of focusing on those instead of just rewriting the rules all over again. You have the review questions. There's just 6 of them. The answer key is posted in the answer key folder, of course. And then your quiz corrections. Remember, if you do the quiz corrections, it's 5 points added to the quiz. But again, if your test grade is higher than that, then of course we'll give you the higher option of replacing your quiz grade with the test grade. As an aside, I know some people didn't get a 100 on their Unit 5 briefcase binder, either because they didn't finish it or it maybe was lacking a few parts. I'm more than happy to regrade it again while I'm grading the Unit 6 one, but just send me an email just so I know to go back and look at the old unit, or else I probably won't, because I won't know to. And then other things like if you need more resources to study, there is an old quiz and really an old test in the answer key folder. That old test is something I definitely recommend looking at, especially as if you have time for the extra practice. Do realize your test tomorrow will be a little bit shorter just because you only have a 40-minute period instead of the usual 55 minutes. There's also an extra homework at the bottom of notes that just deals with even more integration practice. And then, of course, I am going to be grading at the end of the day any recovery that's been turned in. I know several people have turned in recovery. And so I will kind of get that done as well. So today I am going to mainly just answer questions you have, whether like generic questions or specific ones. So yeah, I see Mitchell, your hand's up. What's up?
Yeah, so tomorrow is a Wednesday schedule.
Yes, tomorrow we will be following that Wednesday schedule.
Okay.
Any general questions about your test tomorrow?
Does the test from last year cover all the same things, or are there
The
more that we need
test from
to?
last year covers exactly the same thing as the one for this year. Um, and I'm trying to think on your test, it is mostly just a lot of like find the integral, find the integral, find the integral. The applications you might want to review, and again, these are on the quiz as well. There's going to be one application where you have to solve a differential equation. So you have to integrate, plug in the initial condition, and then solve for C. There's going to be another application where you have to set up a definite integral in order to find area. There's also one like that on your quiz. And then there's also a question dealing with like PVA, which there's one like that on your Unit 5 test. But basically, I could give you something like velocity, and I ask you to integrate to find like position. Or maybe I give you acceleration, ask you to integrate to find velocity. But the vast majority of your test is going to be just like find the integral, find the integral, find the integral. Very similar to the quiz, just with the addition to the inverse trig rules. But yeah, should be a pretty straightforward test. I will let you use a calculator on it, but you can do the whole thing without a calculator. Definitely you can leave your answers unsimplified as usual and all that. Any questions of problems you want me to go over? And these problems can come from the homework, they can come from the quiz, they can come from the briefcase binder, or really anything. Yeah, Mitchell.
So on the homework 0
Mhm.
on 2, it asks to find the, let's see, the critical point. That's when you make that chart, right? With the critical
If you're
point.
just finding the critical point, remember that's going to be where the derivative is equal to 0 or undefined. The second part of that question, yes, is where you make the sign chart.
Sign chart, okay.
I have a couple questions on homework 0 as well.
Yeah.
Okay, so for the second one, part B, the answer key says that, like, when they're taking the second derivative, that, like, when they do the first part of the derivative, it says negative x to the negative third. Wouldn't it just be x to the negative third?
I don't have the answer key in front of me, but I can work it out real fast. So they gave me the first derivative.
Mm-hmm.
So if I'm finding the second derivative, I might simplify this first, just to make it a little bit easier. And so then the second derivative,
Okay.
so I think this is what the answer key had. I don't really remember. Maybe.
Possibly. Okay, then I did something wrong, so that's my fault. And then for part C,
Mm-hmm.
could you do that derivative? Because I'm.
So this one is actually, yeah, so that one you're actually gonna have to integrate, right?
Yeah.
So this is actually a good one to review for the test tomorrow. Make that bigger. So they tell me that f prime of x again is, and I'm just going to rewrite it here so I don't have to keep scrolling, is this. So this is a good review because you do have one like this on your test tomorrow, kind of for everyone. If we want to figure out what the original function f was, well, if I have f prime, I know I want to integrate. Well, if I'm integrating this one, good review, we're dividing by a monomial. When you divide by a monomial, I recommend splitting it up to kind of find the antiderivative, which we are going to go ahead and rewrite this, kind of like I did above. Find the antiderivative and then solve for the c. So the original function, add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent, plus c. So f of x will be equal to negative 2 over x squared plus 1 over x plus c. So that's the antiderivative. And then it tells me that f of 1 is equal to 2. So when you plug in 1 for x, you get the 2 for the y. So that's 2 is equal to negative 2 plus 1, negative 1. So c would be equal to 3.
Okay, I was just being stupid and I don't know.
No, you're fine. But I am going to emphasize on this one a mistake that I saw in the quiz from a few people. Make sure your final answer, whenever you're doing one of these, you always go back and plug in what C is. Another way this question could have been asked, and this is actually how I ask it on your test tomorrow, is I say solve the differential equation. So good reminder for everyone that when you see that solve the differential equation, that's telling you to like find the integral, plug in the initial condition, and then solve for C.
Okay, and then my last question, part 1C,
Mm-hmm.
don't remember how to do that.
In general, I don't want to spend too much time on it because you don't have anything like this on your test tomorrow. But if you want to prove something is continuous, you want to find the limit as x goes to the issue from the left, which is at kind of -3. That's where the split is. You want to find the limit as x goes to -3 from the right. And then you also want to find f of -3. And if it's continuous, then all three of those numbers should be the same. And remember, f of x was given to you up at the top.
Okay, thank you.
Let's see. Armani, I think you had your hand up second.
I have questions from homework 4, part
4?
6. Yeah.
For part 6, you said?
Yeah, A and D.
A and D. So A and D are done similarly. If I can talk. I'll talk about A and then I'll kind of show you D because I actually helped someone with that one last week at some point. So if I'm looking at this one, let's kind of talk about it in general. When we go to integrate a problem, we always want to kind of compare the degrees that we see. The degree we see in the numerator is 1, and the degree we see in the denominator is 2. The difference is just 1, so it's not more than 1, so we know it can't be inverse trig, so it's going to be like a regular U sub. When you do regular U sub, you either let U be the entire denominator or what's like inside of a square root or something like that. So if I let U be that x plus 3 squared plus 16, U prime will then become 2 times x plus 3 to the first. That's like the chain rule. Don't need to worry about it because the derivative of x plus 3 is 1. The 16 goes away. And if you're looking at this, you're like, okay, well, I have 2 times x plus 3, which doesn't quite cancel with 7x plus 21 automatically. But we can see that 7 does go into both the 7x and the 21. So the way you actually finish that one is you have to factor out the 7 from the numerator. So when you go to rewrite it, you have like 7 times x plus 3. The denominator became u, du over u prime. Now the x plus 3's cancel, and you're really just integrating. You have 7/2 on the integral of 1 over u du. We know the integral of 1 over u is the natural log of the absolute value of u plus c. And then what was u? That x plus 3 squared plus 16. D is done similarly, and I worked this one out. I'll just kind of show you the steps to it. Again, the difference of the degrees is just 1, but in this one, the entire denominator is not raised to the first power. There's a square root there, but we can still kind of do it about the same way. We're going to let u be what's inside the square root sign. This one is kind of flipped backwards. We do have like that negative that shows up when we take the derivative. And same thing with the one in part A. We had to factor out the 7 from the numerator, so the x plus 3's would cancel. This one, since the denominator was not raised to the first power, I did have to bring that u up with a -1/2 as the exponent, and then found the integral that way. But that's kind of 2 examples where we had to like factor out something from the numerator to get it to cancel.
So how come you put the whole denominator in as u?
So the only time we wouldn't put the whole denominator as u is when it was something that we knew was going to be inverse trig. So like if I looked at B next to it, I knew that this one had to be an inverse trig problem because the difference of the degrees was more than 1. We had a degree of 0 in the numerator and then a degree of 2 in the denominator. So this one, like if you had let u be the whole denominator, so I'm just going to kind of use what we see in A. If you had let that been your u, then your u prime would have been that same 2 times x plus 3, which has nothing to cancel with in the numerator. So this one is actually, it ends up being an arctangent rule that we can just kind of do directly without u sub because of the degrees that we're comparing. But if you're looking at A, the difference is just 1 in the degree. So we know that a regular u sub would work. And when I say regular u sub, it's like either the entire denominator is u, or what's inside, like an exponent, would be the u.
Okay, thank you.
You're welcome. Brett, you had your hand up next.
Yeah, I mean, I kind of had a similar-ish question, but I was just like, when I did the completing the square stuff, like it made sense, but it wasn't like real intuitive. And like, is there an easy way to tell like I have to do completing the square for this problem, and then like inverse trig as well, or like?
Yeah, so how I determine I have to do completing the square, so let me compare some. Like for me, looking at C, I know I'm going to have to complete the square for 2 reasons. The first reason I know I'm going to complete the square is the difference in the degrees is more than 1. And then the other reason where I know I have to complete the square, so I guess really that told me it was going to be inverse trig. I knew that I would have to complete the square because I see something that is just not in the correct format used for inverse trig, because inverse trig is always going to be something like a squared plus u squared, or it's going to be like a u squared minus a squared, or a squared minus u squared, and that has 3 terms.
Yeah.
If I want to make one up to kind of compare that to real fast, and let's see if I can kind of make one up off the top of my head similar to it. So I'm going to use the same denominator, but instead of a 1 in the numerator, I had something like, let's make it a direct one, 2x plus 6. This one I would not waste my time to complete the square, because I know that it's not going to be inverse trig, because the degree of the numerator is 1 and the degree of the denominator of 2. So this one I know is not inverse trig, it's actually a natural log rule. So it would be a waste of time to complete the square for that one. So I guess like the short answer is like complete the square when it's, it's inverse trig, so when you know the difference of degrees is more than 1, and you don't have that like format in the denominator that works out nicely.
Right. Okay. Thank you.
You're welcome. What's your question?
Number 6 on the briefcase binder on the review problems. I think I just did it like I was just like overthinking it because I don't really know. I just tried it and I couldn't get the answer.
Yeah, so let's talk about this one in general. So again, those of you who maybe not made it this far, let's kind of look at it. So it gives you dy dx, which you know is just like the derivative. It tells you that y is equal to 0 when x is equal to pi over 2. So that's kind of like your initial condition. And you want to find the value of y when x is 0. So you basically want to find y of 0. Well, to do that, you have to know what y is. So the first step is, well, if I have the derivative, how do I figure out what y is? Well, I just want to find the integral, and that's going to help me figure out what y is. So let's talk about the integral for this one first. If I'm integrating this one, some students do mess up and just start integrating each part. But again, this is like a product, and like I don't really know an integral rule for like cosine squared. The proper way to integrate this one is with u sub. So we can say like u would be cosine of x. That's what's inside the exponent. The derivative of cosine is negative sine of x. So rewriting this one, we have the integral of sine of x. Cosine squared becomes u squared du over u prime. Sines do cancel, so we're really just integrating the negative of u squared du. So integrating that, negative comes across, add 1 to the exponent, divide by the new exponent, plugging my u back in. Don't need to worry about, yes we do. And then we have our plus c, and that is what y is. Questions up until that point before I finish it out? All right, so then they have the initial condition. It says y is 0 when x is pi over 2. cosine of pi over 2, that's up at 90. X is 0, so cosine is 0. So that pretty much just goes away. This one's not the most exciting problem because we basically get that c is equal to 0. So if I want to find y of 0, we're going to go ahead and plug in 0 for cosine. And again, remember, c is 0, which is why I kind of left it off there. The cosine of 0 is 1. So we have negative 1/3 times 1 cubed. And that's where the answer came from. Did that answer your questions, Gautam?
Yeah, that makes a lot more sense now.
Yeah, so that one, like if this was on my test, I probably would have phrased it a little bit differently with the whole solve the differential equation, then find like y of 0. But I would use that phrase, since that's what we mainly had been focusing on, that phrase solve the differential equation.
Okay, and I had one more question. It was on
Yeah, go
homework.
ahead.
Yeah, homework 3, number 36.
So first off, I'll still do it if you want me to, but I did said you could skip that one.
Oh, okay. Well, no, then it's fine.
Okay. If you want to do it, like I'm not going to work it out because it's kind of complicated. You actually have to like force split it up into like 2 separate integrals, which is why I did ask you to skip it.
Okay. Thanks.
Armani, what's up?
On the review questions, can you do number 4?
4? Yeah. Also a good one to look at. You definitely have one on your test tomorrow dealing with setting up a definite integral for area. So if I'm looking at this one, do want to have kind of what the graph looks like. This is an exponential function, e to the x. I mean, e to the 1/2 of x, but in general, we know all exponential functions look something like this. And so that's my function. And we have x is equal to 0, which is the y-axis. X is equal to 2, which is somewhere out here. Again, that's just a vertical line. Y equals 0, which is the x-axis. So it's basically asking me to find that area. If this was on your test, I probably would give you a graph, even though I would hope that most students know kind of what that graph looks like. But when you are doing this problem, even on your test, there's certain things I'll be looking for. I'll always look for your definite integral setup. So this area is starting at 0, ending at 2. What are we finding the area of? We're finding the area under e to the x over 2 with respect to dx. That's be the first kind of points I would give you. The next set of points will be basically your antiderivative. U sub technically for this one, some of you could probably do this in your head. Remember, for an exponential function, u is always the exponent. So u would be x over 2. So u prime, x over 2 is just the same thing as 1/2 of x. So u prime would just be 1/2. So if you think about it, you're really just integrating e to the u. Du over u prime over 1/2 is going to be the same thing as multiplying by 2. What's the antiderivative of that? So I have the 2 that is a coefficient. The integral of e to the u is just e to the u. And then this was a definite integral, so we're going to plug in the top number minus plug in the bottom number. So that's where the next set of points will come from, your actual antiderivative. And then as area, making sure you always plug in the top number minus plugging in the bottom number, which that reduces to 2e to the first power minus 2. Anything to the 0th power is 1, so that's just a 2. And then you're looking for an answer that matches that, which is going to be c when you factor out that 2. But key things I would be looking for if I was grading this problem, say this was a test question, I would look for a definite integral setup. I would look for the antiderivative, and then I would look for where you plugged in the top number minus the bottom number. Any other questions?
Mr. Brown,
Yes.
On the actual AP exam, this would just be like 1 point, like you get it or not, right? Because it's multiple
Yes,
choice.
on the AP exam, multiple choice, it's right or wrong, no partial credit. Yeah.
Got it.
And this one on the AP exam would have been on the no calculator section.
Mr. Brown,
Yeah.
I just have a general question. So when I took the quiz, there was this one problem that required you to like draw a graph. So my question is like, when do you know when to draw a graph on a question?
Okay, so there's two types of questions I would probably draw a graph on if it wasn't provided. The first type of question would be if you're doing an area question. It's like, here's the one, this is first period's version, but if you didn't have a graph there, then I would definitely want to find the, like, have a visual of it. So like have the graph either in front of you, whether it was provided or not provided. The one question that people kept missing, this is actually going back to Unit 5, where you have to draw a graph and sometimes left it off, and this is from the Unit 5 test, so not really one like this on your test tomorrow. But for absolute value functions, you have to draw the graph to evaluate a definite integral using geometry. But you don't have any of those on this test.
So when it's an absolute value, you have to draw a graph?
Yes, because there's no rules for integrating absolute value.
Okay.
Any other questions?
Can you do number 30 on homework 3?
30, you said?
Yeah.
Yeah. All right, so if I'm looking at 30, again, kind of things going on in my head when I approach this one. Yes, it's a definite integral, but I would probably first try to figure out how to integrate it first, like kind of ignoring those numbers. And two options you can kind of go through. You might look at this as like a regular u sub where you would let u be the entire denominator. And in fact, if you let that happen, so this is actually what we're not going to do, but I want you to kind of see why it ends up being the wrong answer. Because some people still try to do it this way. So if you let u be the entire denominator, and then when you find u prime, the 1 goes to 0. And this sine squared, you have to use the chain rule, so its derivative becomes like 2 times the sine of x times the derivative of the inside, which is cosine. And you can look at that and be like, okay, that is definitely not canceling out with just the cosine. And so, like, a regular u sub just wouldn't work for that problem. We know it wouldn't work because what we want to just cancel out is the cosine. This is one of the tricky ones where it's kind of like a inverse trig problem in disguise. How I know it's an inverse trig problem in disguise is like we do have kind of like those two terms in the denominator. If it is an inverse trig, then like our a value is just 1, which makes it a little bit easier to deal with. And we only want u to be what is being squared. So like if u is equal to sine, the derivative of sine is cosine, and we can automatically see that that is going to make it a lot easier for us. Because when we go to rewrite this, again, I'm going to drop off the numbers for now, by the integral of the cosine of x over 1 plus, that's now u squared, du over u prime, and now the cancellation works out how we want it to. So what rule again has 1 plus u squared in the denominator? This is arctangent, so I have 1 over a, and again, a is just 1, so this is literally just going to become the arctangent of u over a, where u is the sine of x, and then that will be your answer. Or that will be your antiderivative, and then you could plug in the top minus the bottom. Do you want me to keep going to remind you how to evaluate the inverse trig?
No, it's fine. I get it now.
All right. But yeah, this is one I think is tricky only because it ends up being like an inverse trig problem in disguise. And you can definitely see, probably expect to see one similar to that on your test tomorrow.
Okay, and could you also do number 40?
40, looking at it, this is kind of a good one also to springboard off of the question that Brett asked kind of earlier. So in things I do when I look at this one, and kind of what goes on in my brain is the degree in the numerator is 0. The largest exponent I see in the denominator is 2. So the difference is actually more than 1. So I know that this is going to have to be inverse trig. Well, if it is inverse trig, then I look at this, and this issue right now is really with what we see inside of that square root. And specifically what's giving me the issue is this 2x. Like if this truly was inverse trig, like it would be an arcsecant because we do have something outside the square root sign. But that should be like a number. Like it should be like x squared minus a squared. And a is just a number without a variable in it. This is actually one where we know that we would have to get it into the right format. How do we get it in the right format? We want to complete the square. So I have x squared minus 2x. Leave a whole gap. Not really constant, but we can still complete the square. So I'm going to go ahead and add b over 2 squared. But what we add, we also have to subtract. The first 3 terms will become the binomial squared. It's going to be a minus. 2 divided by 2 is the 1. And then we have minus 2 divided by 2 is 1. That just becomes 1 squared, or 1. What's the whole point of completing the square? Is it allows us to rewrite a problem so it's in a better format. Now this does look directly like an arcsecant rule. And again, I know it's arcsecant because what is being squared is exactly on the outside. Don't need to worry about u sub too much because the derivative of x minus 1 is 1. So the antiderivative of this, we have 1 over a. A is 1, so it's just going to be the arcsecant of the absolute value of u over a plus c. So that's a good example of just reviewing how we complete the square to get it into the right format.
Wait, so you complete the square when the difference between the numerator and denominator, like in terms of degree, is more than 2?
I complete the square, yes, when the difference of the degrees is more than 1. But mainly I complete the square when it's not in the correct format. So like, did I write the rule? So like the rule is, I'll kind of just go off to the side. Like for a secant one, it's the integral of 1 over u on the square root of u squared minus a squared is the arcsecant of u. Like that's the rule that we have memorized. This has to show up exactly for us to be able to use the arcsecant rule. In this problem, we didn't have that because where this is minus a squared, that has to be a number. This one had like a variable here, so we didn't have an a squared value yet. By completing the square, we fix it so we do now have just a number there that we're subtracting to use the formula correctly, if that makes more sense.
Yeah, but when you're completing the square, don't you also have to, whatever you're completing it, don't you also have to add that to the numerator?
We don't ever add to the numerator. No, what we end up balancing is like what we end up adding, we also have to go back and just subtract in that same line.
Oh, okay. Oh,
so
right.
Like we are balancing it, but not like numerator to denominator. We're just kind of balancing it along that same row.
Oh, okay. That makes more sense.
Yeah, so like another example, just to kind of make it a little more obvious. Like here's the one we did in kind of the notes. So you can see like whatever you add, you also had to subtract to kind of keep it balanced. But we never really did anything in the numerator.
Oh, gotcha. Okay, that makes more sense. Thank you.
You're welcome. Any other questions, guys? Enrique, go ahead.
So on homework number 3, like the first question on number 4, I thought I could go straight to U sub, but then in the answer key it kind of like canceled out the 9 by multiplying it with 1/9.
So there's 2 ways to do this one. My preferred way often is to do U sub. So more of you are probably inclined to do it that way because when I just do problems, I tend to do it with U sub. Right, so that's one way to do that problem. The other way to do that problem is to avoid U sub. And how you can avoid U sub is if this was just an x squared, you can avoid doing U sub entirely. How can you avoid it? If you factor out a 9, you end up with this. But you're going to end up with like the same answer.
Okay.
You just have in this with U sub you have like an a value of 1. If you factor out that 9, your a value becomes 1/3, but it all like the way the numbers work out, you get the same answer.
Okay, thank you.
You're welcome. Any other questions, guys?
Can you go back to homework 4?
Mm-hmm.
Also part 6 again.
Part 6. Mm-hmm.
On part E, can you take the negative out of the denominator, or are you supposed to like complete the square with it?
So when I'm completing the square for this one, that negative has to stay inside the square root. But like I would factor it out. So you have something like this. And then that will become like a -7. So I'm going to add 6/2 squared and also subtract the 6/2 squared. So we have this negative still. And then that's going to become x plus 3 squared when I complete the square. And then this is going to become -7 minus, what is that? 9. So minus the 16. And this is a mistake that happens is people just want to like move that negative like in the very front. But that negative is inside the square root, and we can't do that. So how to get rid of it is just kind of like factor it back across, distribute it back across, and that will become a positive 16 and negative x plus 3 squared. So what you're really integrating is 1 over the square root of 16 minus x plus 3 squared, which then actually makes more sense because now it is in the arc sine formula, where a is 4, there's your u, u prime is 1, so that's how we're going to get the no 1 over a in front, but the arc sine of u over a plus c. Lily.
So I know you already did number 6, letter A, but can you go back to it really quick?
Yeah.
So you didn't complete the square for that one, but you can, it just takes longer,
like,
right?
Yeah. Well, this one, like I have it in this section because technically I've already completed the square. Like that's
Okay.
what that format came from.
Okay.
But if you had, like, how can I say it?
I just like foiled out again, and then I like it.
So
just
yeah,
was
if you
steps.
foiled it out, you would still end up with the same answer eventually.
Okay.
You might have to. The only difference is when you have your u, your u prime might be like 2x plus 6.
Yeah.
And so you would have to like factor out the 2 to get it to work out correctly.
Okay.
But it wouldn't be wrong. It just probably would be a little bit more time than you have to use.
Okay.
Any other questions for y'all's test tomorrow? All right. Well, that actually does take us to the end of class. I do appreciate all the questions y'all asked. There's definitely some classes earlier today where I